to Aero Orbit Mind here. Curiosity takes flight. Whether you're exploring mathematics, physics, aerospace engineering, computer science, or the wonders of the universe, every lesson is a step toward understanding how our world works. So grab a notebook, stay curious, and let's start learning. Flight dynamics is the study of the performance, stability, and control of vehicles flying through the air or in outer space. It is concerned with how forces acting on the vehicle influence its speed and attitude with respect to time. In fixed-wing aircraft, the changing orientation of the vehicle with respect to the local airflow is represented by two critical parameters, angle of attack alpha and angle of sideslip beta. These angles describe the vector direction of airspeed, important because they are the principal source of modulations in the aerodynamic forces and moments applied to the aircraft. Spacecraft flight dynamics involve three forces: propulsive rocket engine, gravitational, and lift and drag when traveling through the Earth's or any other atmosphere. Because aerodynamic forces involved with spacecraft flight are very small, this leaves gravity as the dominant force. Aircraft and spacecraft share a critical interest in their orientation with respect to the Earth horizon and heading, and this is represented by another set of angles: yaw, pitch, and roll, which angles match their colloquial meaning, but also have formal definition as an Euler sequence. These angles are the product of the rotational equations of motion, where orientation responds to torque, just as the velocity of a vehicle responds to forces. For all flight vehicles, these two sets of dynamics, rotational and translational, operate simultaneously and in a coupled fashion to evolve the vehicle's state orientation and velocity trajectory. Flight dynamics is the science of air vehicle orientation and control in 3 dimensions. The 3 critical flight dynamics parameters are the angles of rotation in 3 dimensions about the vehicle's center of mass, known as roll, pitch, and yaw, quite different from their use as Tate-Bryan angles. Aircraft engineers develop control systems for a vehicle's orientation attitude about its center of mass. The control systems include actuators, which exert forces in various directions and generate rotational forces or moments about the center of gravity of the aircraft, and thus rotate the aircraft in pitch, roll, or yaw. For example, a pitching moment is a vertical force applied at a distance forward or aft from the center of gravity of the aircraft, causing the aircraft to pitch up or down.